So good day everyone, good day sir. So today I'm going to discuss to you about the testing requirements for standard test methods for small clear specimens of timber. So the scope. These methods cover determination of various strength and related properties of wood by testing small clear specimens. And these methods represents the procedure for evaluating different mechanical and physical properties, controlling factors such as specimen size, moisture content, temperature, and rate of loading. So as a summary for the methods, the mechanical tests are the static bending, compression parallel to grain, impact bending toughness, compression perpendicular to grain, hardness, shear parallel to grain, cleavage, tension parallel to grain, tension perpendicular to grain, and nail withdrawal test. In addition to methods for evaluating such physical properties as specific gravity shrinkage in volume, radial shrinkage, and tangential shrinkage are presented as well. So first, we go to the procedure for the various tests. So first would be the photographs of specimens. So 4 of the static bending specimens from each specimen should be selected for photographing. So there are 2 average growth, 1 fast growth, and 1 slow growth. As you can see here up in these images. So these specimens shall be photographed in cross-section and on the radial, tangential, and tangential surfaces. So second procedure would be the control of moisture and content temperature. So in recognition of the significant influence of temperature and moisture content on the strength of wood, it is highly desirable that these factors be controlled to ensure the comparable test results. So the control moisture content procedure is first, the specimen for a test in the air dry condition shall be dried to approximately constant weight before the test. And second would be, it should any changes in moisture content occur during the final preparation of specimen, the specimens shall be conditioned to constant weight before the test. So last procedure is, it is desirable that the testing room and rooms for preparation of test specimen have some means of humidity control. And the third procedure would be the record of hardwood and softwood. So the proportion of softwood is first, the estimated portion of softwood percentage should be recorded for each test of specimen. So this would be the softwood, this area, outside area, the outermost area, and the hardwood would be the innermost area. So proceed to the next procedure. So the next procedure would be the static bending size. The static bending size composed of the size of specimen, loading, span, and supports, bearing block, placement of growth rings, speed of testing, load of deflection curves, description of static bending failures. So for the specimen size, the static bending test shall be made on by 2 by 2 by 30 inches. Secondary methods, the actual height and width at the center and the length shall be measured also. So for the loading, span, and supports, use center loading and span length of 28 inches for the primary method, and 14 inches for the secondary method. So for the bearing block of the form of size that's shown in the figure here. Here in the bearing block, in the bearing, and having a radius of 11 by 11 or 2 inches or 38 millimeter for a cord length not less than 2 inches, and 50 millimeters should be used for secondary method of specimen. So for the placement of growth rings, the specimen shall be placed so that the load will be applied through the bearing block to the tangential surface nearest to the pith. So for the speed of testing, the load shall be applied continuously throughout the test at the rate of the motion of the movable crosshead of 0.10 inches. So load of deflection. Load of deflection curve shall be recorded to or beyond the maximum load for all static bending tests. So for the description of static bending, failures shall be classified in accordance with the appearance of the fractured surfaces and the manner in which the failure develops. So we go to the next procedure. This procedure would be the compression parallel to grain. So this composes of the size of specimen and surfaces parallel, speed of testing, load compression curves, position of test failures, description of compression failures, weight and moisture content, and lastly, the ring and latitude measurement. For the size of specimen, the compression parallel to grain test shall be made on by 2 by 2 by 8 inches or 50 by 50 by 200 millimeter for the primary method of specimen, and 1 by 1 by 4 inches or 25 by 25 by 100 millimeter for the secondary method of specimens. So for the end surfaces parallel, ensure that the end grain surfaces will be applied parallel to each other and at right angles to the longitudinal axis, and at least one platen of the testing machine shall be equipped with a spherical bearing to obtain the uniform distribution of load over the end of the specimen. So for the speed of testing, the load shall be applied continuously at the rate of the motion of the movable cross head of 0.003 inches of nominal specimen length over minute or length per minute. So for load compression curves, the load compression curves shall be taken over a central gauge length not exceeding 6 inches or 150 millimeter for primary method of specimen, and 2 inches or 50 millimeter for the secondary method of specimen. So for position of test failures, in order to obtain satisfactory and uniform results, it is necessary that the failures be made to develop in the body of the specimen. And for the description of compression failures, the compression failures should be classified accordance with the appearance of the fractured surfaces. Two or more kinds of failures develop, all shall be described in the order of their occurrence and appearance. So the weight and moisture content. The specimen shall be weighed immediately before the test and after the test. The moisture section approximately 1 inches or 25 millimeter in length shall be cut from the specimen near the point of failure. And for the ring and late wood measurement, when the practicable, the number of rings per inches and the proportion of summer wood shall be measured over a representative inch of cross section of the test of specimen. So for the next procedure, the impact bending. So the impact bending composes of size of specimen, loading and span, bearing block, placement of growth, procedure, weight of hammer, deflection records, drop causing failure, description of failure, weight and moisture content. So for the size of specimen, the impact test shall be made on by 2 by 2 by 30 inches or 50 by 50 by 760 millimeters specimens. The actual height and width at the center and the length shall be measured also. So for the loading span, use the center loading and span length of 28 inches or 710 millimeter. Bearing block. A bearing block is a metal top of curvature corresponding to the bearing block shown in the figure. So here it is. And for the placement of growth rings, the specimen shall be placed so that the load will be applied through the bearing block to the tangential surfaces nearest the pith. So for the procedure, first procedure is make the test by increment drops in the hot tanner or similar impact machine. See in the figure, this is the hot tanner impact machine. And the first drop will be 1 inches or 25 millimeter, after which increases the drops by 1 inches. The increments until the height of 10 inches or 250 millimeter is reached, then use a 2 inches or 50 millimeter increment until completed the failure occurs at 6 inches or 150 millimeter, and then the deflection is reached. So for the weight of hammer, 50 pound or 22.5 kilogram hammer shall be used when the drops up to the capacity of the machine about 68 inches or 1.7 meters. For the small hot tanner impact machine, it is practically certain that complete failure or a 6 inches or 150 millimeter deflection will result. For the deflection records, the graphical drum records giving the deflection for each drop and the set, if any, shall be made until the first failure occurs. So the drop causing failure. The height of drop causing failure, either complete failure or 6 inches or 150 deflection, shall be observed for each specimen. For the description failure, shall be sketched on the data sheet and described in accordance with the direction for static bending in 8.7 inches. Weight and moisture content. So first, the specimen shall be weighed immediately before the test and after the test. The moisture section approximately 1 inches or 25 millimeter in length shall be cut from the specimen near to the point of failure. So for the next procedure, we have toughness. So in line with the toughness, it will be the size of specimen, load and span, bearing block, apparatus, and procedure, calculation, weight and moisture content. So for the specimen size, the toughness test shall be made on by 0.79 by 0.79 by 11 inches or 20 by 20 by 280 millimeters of specimen. So for the loading span, center loading at the span length of 9.47 inches or 240 millimeters shall be used. The bearing block is an aluminum top, as we can see here in the figure, having the radius of 3/4 inches or 19 millimeter shall be used in applying the load. So for the apparatus and procedure, the test in pendulum type toughness machine, this is toughness test machine or test assembly. And before the test, the machine before the test, so that the pendulum hangs vertically and adjust it compensates for friction. And for the calculation, we have the formula here. T is equal to WL cos A1 minus cos A1. A2 cos A2 minus cos A1, where T is toughness, W is weight of pendulum, L is the distance from the center to the supporting axis of the gravity of pendulum, A1 is the initial angle, A2 is the final angle. And for the weight and moisture contents, so the specimen shall be weighed immediately for the test and after the test. Moisture section is approximately 2 inches, 50 millimeter. In the length shall be cut from the specimen near the failure. The next procedure is the compression. Compression pendulum perpendicular to grain. Then it is the size of specimen, loading, placement of growth rings, speed of testing, load compression, and weight of moisture content. So for the size of specimen, it is made up on by 2 by 2 by 6 inches or 50 by 50 by 150 of specimens. So for the loading, should be applied through the metal bearing plate by 2 inches or 50 millimeter in width, placed across the upper surface of the specimen at equal distance from the ends of the right angle to the length of the apparatus. So for placement of growth rings, the specimen shall be placed so that the load will be applied through the bearing plate to the radial surfaces. And for the speed of testing, the load shall be applied continuously throughout the test at the rate of motion, the movable cross head of 0.012 inches or 0.305 millimeter. For the load compression curves, load compression curves shall be taken for all the specimen up to 0.1 inches or 2.5 millimeter compression, after which the test shall be discontinued. The deflection reading shall be taken to 0.0001 or 0.002 millimeter. And for the next procedure, hardness. So for the size of specimen, the hardness test shall be made on by 2 by 2 by 6 inches or 50 by 50 by 150 millimeter of specimen. So the procedure, use the modified ball test with a ball 0.444 in inches or 11.3 millimeter in the diameter for reading hardness shown in the figure. And for the number of penetration, 2 penetrations will be made of tangential surfaces, 2 on the radial surfaces, and 1 on the each end. So for the speed of testing, the load shall be applied continuously throughout the test. The rate of motion of the movable crosshead of 0.25 inches or 6 millimeters per minute. So the weight and moisture content shall be weighted immediately before and after the test. Moisture section approximately 1 inches or 25 millimeter in length shall be cut. For the shear and parallel to grain, so this section describes one of the making shear parallel to the grain test has been used for found satisfactory. So for size of specimen, the shear parallel to grain test shall be made on by 2 by 2 by 21 inches or 50 by 50 by 63 millimeter of specimen notch in accordance with the procedure field. So the procedure, use a shear tool similar to that illustrated in the figure here, providing a 1/8 inches or 3 millimeter offset between the inner edge of the supporting surface placed in the plane of the adjacent edge of the loading surfaces, and then apply the load to the support specimen to the end grain surfaces. Take care in placing the specimen in the shear tool to see the crossbar is adjusted so that the vertical edges specimen are vertical and the end rest evenly on the supported over the contact area. So the speed of testing load should be applied continuously throughout the motion of crosshead of 0.024 inches or 0.6 millimeter per minute. For the test failures, shall be sketched on the data sheet. In all cases where the failure at the base of the specimen extend back onto the supporting surfaces, the test shall be called moisture content. The moisture content is the proportion of test piece that is sheared off shall be used as the moisture specimen. So for the cleavage procedure, Cleavage procedure, there would be size of specimen, procedure, speed of testing, sketch of failure, and measure content. So the size of the specimen for the cleavage is test specimen size in accordance with the figure here. It would be 0.75, 0.523 inches. In millimeter, it would be 6 millimeter, 13, 50, and 78. So for the procedure, the specimen shall be held during the test in grips as shown in the figure here. And observe the maximum load only. For the speed of testing, it would be applied continuously throughout test at the rate motion of the movable crosshead of 0.10 inches or 2.5 millimeter per minute. So for the sketch of failure, failure shall be sketched on data sheet also. So for the moisture of content, one of the pieces remaining after failure, cross-section split on the surface of failure shall be used as a moisture for the specimen. So for the tension parallel to grain procedure, there will be size of specimen, procedure, speed of testing, sketch of failure, moisture content. So for the size of specimen, in inches, it would be 3/8, 1, 2 and 1/2, 3 and 3/4 in inches. And for the millimeter, it would be 9.5, 25, 63, and 95 millimeter. So the procedure, so fasten the specimen in the special grip shown in the figure here. So this is the tension parallel to grain test assembly. So the deformation shall be measured over 2 inches or 50 millimeter central gauge length of all the specimen. Take load extension readings until the proportional limit is passed and read the deformations to 0.0001 inches and 0.002 millimeter. The speed of testing is applied continuous throughout the test. The rate of motion of the movable crosshead of 0.05 inches or 1 millimeter per minute. So as for the sketch of failure, it should be sketched on the data sheet for the moisture content. So the moisture section about 3 inches or 76 millimeter in length shall be cut from the deducted and near to the failure. And for the tension perpendicular to grain, the size of specimen, procedure, speed of testing, sketch of failure, and moisture content. So for the size of specimen, so this here. So for the inches, it would be 0.75, 0.512. And for the millimeter, it would be 6, 13, 25, 50 millimeter. So the procedure, fasten the specimen during the test in grips as shown in figure 32 here and 33. here. Observe the maximum load only. So for the speed of testing, the load should be continuous throughout test at the rate of motion of the movable crosshead of 0.10 inches or 2.5 millimeter per minute. So the sketch of failure shall be sketched on the data sheet. The moisture content. So one of the pieces remaining after failure section split along the surface failure shall be used as moisture specimen. So for the nail withdrawal, so there will be nails preparation of specimen procedures, speed of testing, weight and moisture content. So for the nails, it is used for the withdrawal test shall be 0.0985 inches or 2.5 millimeter in diameter. So preparation of specimen. So the nail shall be driven at the right angle of to the face of the specimen to a total penetration of 11 or 4 inches or 32 millimeter. Two nails shall be driven on the tangential surfaces, two on the radial surfaces, and one on each end, as shown in the figure. So the procedure. So first, withdraw all 6 nails in a single specimen immediately after driving them. Fasten the specimen during the test in grips as shown in figure 35 here. And observe the maximum load only. Speed of testing. It is applied continuous throughout the test at the rate of motion full crosshead of 0.075 inches or 2 millimeter per minute. So the weight and moisture content, and the weight immediately before driving the nails after the test, and the moisture section approximately 1 inches or 25 millimeter in length shall be cut from the specimen. So next procedure, the specific gravity and shrinkage in volume. So for the size of specimen, the specific gravity shrinkage and the volume test shall be made of on green 2 by 2 by 6 inches or 6 by 6 by 150 millimeters of specimen. So the procedure first is obtain both specific gravity of shrinkage in volume determinations of the same specimen. So second is the carbon impression of the end of the green specimen may be back to the data sheet in like manner. So for the final measurement, measurements of mass and length shall be made on the oven dry specimens, and the method of measurements shown in the figure for radial and tangential shrinkage test assembly. The method of making the radial and tangential shrinkage measurement is an ordinary micrometer is required. Accuracy is suited for this measurement. So for radial and tangential shrinkage, so for the size of specimen, it is 1 by 4 by 1 inches or 25 by 100 by 25 of specimen cut from 1 by 4 inches or 25 by 100 millimeter board. So for the initial measurement, the length of all the specimens shall be measured. So for the weight, the specimen shall be weighted when green after the circuit oven drying. So for the drying, first the green specimen shall be open piled and allowed to air seasoned under the room conditions is uniform moisture content approximately 12%. For the final measurement, measure the mass of the length made by the oven dry specimen. So method of measurement shown in the figure. So illustrates the method of making the radial tangent shrinkage measurement. It is required an accuracy for this measurement. So for the moisture determination, first will be the selection. Sample for the moisture determinations for each test specimen shall be selected as described for each test. For the weighing, immediately after obtaining the moisture sample, all loose splinters shall be removed and the sample shall be weighted accordingly. So, drying. The moisture sample shall be open piled in an oven and dried at temperature of 103 to 62 degrees Fahrenheit until approximately constant mass is attained, after which oven dry mass shall be determined. The moisture content, loose mass expressed in percent of the oven dry mass as determined, shall be considered the moisture content of the specimen. So for the most unpermissible variations, so the mass of the specimen and of moisture sample shall be determined to an accuracy of not less than 2%. The measurement of the test specimens shall be determined to an accuracy not less than 0.3%. Testing machine speed should not vary by more than 25% from the specified given test. So for the calibration, all the apparatus used in obtaining data shall be calibrated at sufficiently frequent intervals to ensure accuracy. Also, for the precision and bias, for these statements of precision and bias for the test have not yet been developed, not yet been developed. So that will be all. Thank you.